first time we see congruence is relating to transformations. When a shape is translated, reflected or rotated, its image is congruent to the original shape. When we enlarge a shape though, it's not congruent. Two shapes are congruent if they're the same shape and size. Obviously enlarged shapes aren't the same size. A way to remember this is to think of your shapes as a physical piece of paper. A shape is congruent to the original if it can still be made by using the same piece of paper. So what I've got here is some transformations and my original shape cut out of a piece of paper. When I translate my shape, I can do this with my paper. I just slide it over. With reflection, I pick up my paper and flip it over and I can make the new image. With rotation, again, I can still make the new image. So all these shapes so far are congruent. But with enlargement, I can't turn my piece of paper into that new image. I've no magical method of stretching it. If I want to make this shape, I'll have to get another piece of paper. With congruent shapes, all the lengths and all the angles are the same, which is the problem here. The sides of my shape don't match the new one. With enlargement, the shapes aren't congruent, but they are similar. Similar shapes are by definition enlargements of each other. The lengths of the sides have changed, but all in proportion to each other. This leaves us with the same shape, with the same angles, only bigger. So if we want to prove that two shapes are congruent, we have to prove that the angles are the same and also the sides. Just proving that the angles are the same will prove that two shapes are similar, but we need the side lengths to be the same for them to be congruent.